Welcome to this brand new solution video of question paper 1 times out 1 of applications and interpretation paper 1. If you like this video, please give it a thumbs up and subscribing to my channel will be awesome. If you think there is some improvement area, please let me know in comments. I will take care of that in future. Let's talk about question number 1. The height of a baseball after it is hit by a bat, it is modeled by the function this. Whenever a ball or anything that is that goes into the air, this is a very common kind of equation. The constant part is the value from where it starts going into the air. That means the height of the bat was 1.2 meter above the ground, because that is here, and then it went like this and fell on the ground, and this is the ground. This is how I interpret this one, where ht is the height, of course, in meters above the ground, and t is the time in seconds. So time is going this way, height is this way. Okay, write down the height of the ball above the ground at the instant it is hit by the bat. And see, without looking at this part, I knew that 1.2 meters is the height, but how? When ball is hit, time is 0, right? The moment it hit the bat, time started. So time was 0 then. So I'll write h0. The height at time equal to 0 will be minus 4.8, 0 square, 21 times 0 plus 1.2. 0 square is 0 and multiplied by anything is 0. This is 0, and of course we get 1.2 meters. But make it a habit that is such a function. This is where it starts from. B. Find the value of t when the ball hits the ground. Ball is hitting ground here. What is the height here? 0, right? Hypothetically, if time was negative, it would be starting from this particular place, right? So if I write this height equal to 0, I will get 2 times, because this is quadratic equation. One time will be here, which will be negative time, we will ignore. One time will be here, will be positive, we will accept it. And that's what I'm going to do. Height is 0 is equal to minus 4.8 t square plus 21t plus 1.2, and just we need to how much? 2 marks only. So we just have to solve this particular equation. Let me use my calculator for doing. And when I used my calculator, I got 2 times. One was 4.43 seconds, and one we got negative 0.056 as expected. Time cannot be negative, so we reject this time, and this is the time when it hit the ground. Okay, C part. State appropriate domain for t in this model. Whatever is our x-axis, kind of horizontal axis we call this, here it is t-axis. The domain belongs to that. And what is the minimum value for time? 0. Time cannot be negative, we said. So from 0 to this time, which was 4.43, is the domain, and we will write it as 0, and t is between 0 and 4.43. This is how we answer the first question. Question number 2. Question number 2 says the ticket prices for a concert are shown in the following table. Adult is $15, child 10, and student 12. A total of 600 tickets were sold. The total amount of money from ticket sale was this. There were twice as many adult tickets sold as child tickets. So let's give them some alphabets first. So adults, number of adult tickets, let's call them A. So this is number of adult tickets called A. Child tickets, C, and students ticket, S. Now first a total of 600 tickets were sold. So A plus C plus S is 600. That's how we interpret this. The total amount of money from tickets sale was 7816. So let's focus on this one. If one ticket for adults costed $15, what about a number of adults? So one adult 15, two adults, 2 times 15, 30, three adults, 3 times 15, 45, a number of adults, it will be a times 15, which is 15a, right? And this is the amount earned from selling those tickets, a times 15. Similarly, the amount earned from child will be c times 10, which is 10c, and this will be 12 times s. And total amount, this amount plus this amount plus this amount is 7816. So we'll make an equation based on this. This is equation number 1. Equation number 2 is going to be 15a from here plus 10c from here plus 12s equal to 7816, equation number 2. There were twice as many adult tickets sold as child tickets, which means A is 2 times C. Adult tickets sold twice as child tickets. So this is equation number 3, and now we can get an equation from here and here, so that A and C we need for third. So we'll get rid of this S from here. So I will multiply this equation number 1, which is this one, by 12, so that I get 12s, and I can cancel this 12s later. So 12, this equation multiplied by 12 becomes 12a plus 12c plus 12s equal to 12 times 672. And now we will subtract this equation, 15a plus 10c plus 12c, 12s equal to 7816. Since we are subtracting, everything will be negative here. So 12 minus 15 is minus 3a. 12 minus 10 is 2c. They cancel out. That was the purpose. Equal to negative, because this is more, right? 616, 616. Now we have equation in terms of A and C have this relation. That's why I focused on eliminating S. So now we'll substitute A by 2C. So we'll write minus 3. A is 2C plus 2C equal to negative 616. So negative 6C plus 2C is negative 616, negative 4C equal to negative 616. Divide both sides by negative 4 to get the value of C. 4 and 4 cancel, and these become positive. We get 154 tickets for children were sold. What is the A part saying? Write down 3 equations that express the information given. Now I have already done that without reading the question. Find the number of each type of ticket sold. So we'll write first children tickets sold are 154. Now we can find adults tickets will be how many? We know that adults tickets were twice the children, so we can write 2 times 154, which is 308. And they said a total of 600 tickets were sold. So what is the third type? Students. So add these two. Let me write, will be equal to 600 total minus, we'll subtract the previous two, 154 plus 308, which will be 462. So 138, right? Yeah, 138 tickets. So second part is also answered. 154, 308 and 138 tickets sold for each one of them. Okay, moving on to question number 3. Leo is investigating whether a six-sided die is fair. He rolls the die 60 times and he records the observed frequencies as follows. Leo carries out a chi-square goodness of fit test at 5% significant level. Alright, write down the null and alternate hypothesis. So, he investigating whether the six-sided die is fair. So, our null hypothesis, A part, null hypothesis, this die is fair if probability of 1 is equal to probability of 2 equal to probability of 3 and so on. This is our null hypothesis, that all the probabilities are equal, the die is fair. So alternate hypothesis will be probability of 1 is not equal to probability of 2, which is not equal to probability of 3 and so on. Alright, part B, write down the degree of freedom. So we have, if I start with 1, I'll have degree of freedom, the other remaining data. So it is always degree of freedom is n minus 1. So we have 1, 2, okay, we have 6. So it will be 6 minus 1 equal to 5 in this case. C, write down the expected frequency of rolling a 1. If they are fair, the probability of 1 will be 1/6, right? And we are rolling it 60 times total. So expected value, expected times, it will be 1 is 10. So expected frequency is 10, whether the real one, observed one, is 8. Okay. Find the p-value for the test. Okay, for the p-value, we need to know chi-square first. So chi-square is sigma observed minus expected square, the frequency we are talking about, and over expect. This sigma is above all of them. So we'll have to find this this value for all of them. So let's start with 1. The outcome 1. So observed for 1 is 8. Expected, we just got 10 square over 10. Similarly, for 2, it will be 7 minus 10 square over 10. Okay, so I've found all the values, and now I'll find their sum. Sigma means add all of them. So 1.3, 2.9, 5.4, 5.8, 6.2. 6.2 is chi-square. Let's look at the table. For this, the degree of freedom we can see is 5. This is 5. And our chi-square value came out to be 6.2. So in 5, 6.2 will be somewhere here, right? Here. I don't have the right calculator right now, but we know it will be between 0.2 and 0.97, but the gap is too much. Okay, and it is not a linear gap. Okay, so I can't straight away guess what is the value, but I know it is more than 0.2. So you can use your calculators or some different means to find this D. For D, p value is greater than 0.2. That's what I know. And E, they say they state the conclusion of the test. Give a reason for your answer. 0.2 is much more than 0.05, because they have given the significance level. Can you see? 5% significance level means 0.05 if I convert that to decimals. And if our p-value is more than that, that means we are not sure to change. The evidence is not enough to reject the null hypothesis, so we fail to reject null hypothesis. That means with the null hypothesis that the die is fair. Okie dokie, let's go to question number 4. And this question number 4 talks about a tree diagram. Yeah, Carl has 3 brown socks and 4 black socks in his drawer. He takes 2 socks at random from the drawer. Complete the tree diagram. Okay, so we'll complete it now, because 3 out of 7, there are 3 plus 4, right? Can you see here? 3 plus 4, 7. 3 out of 7 are brown. That's why it is here. So the sum of all the branches from the same point is always 1. This will be 4 out of 7, so that their sum is 1. It is 2/6. This will be 4/6. Now, we have to fill both of them here. So now we'll have to look at the logic. 4 out of 7, the first sock. If we reach at this branch, it is confirmed that the first sock is black. So one black sock is gone now. So we are left with 3 out of remaining 6. Okay, and that's why the probability of brown, not black, will be 3/6, right? But obviously black will be 3/6, and because the sum has to be 1, so it will be 3/6 again. If you want to simplify these, you can simplify. It is 1/3, it is 2/3, half and half. Okay, find the probability that Carl takes 2 socks of the same color. So they're asking what is the probability that it is brown and brown, or probability of black and black. Okay, so let's say brown and brown from this branch here. Brown and brown, 3/7 times 1/3. Whenever there's and, that means it is happening one after another, so the probabilities have to multiply. Or black and black. Black is 4/7 and half. That's black and black, and they are of same color in these 2 cases only. Otherwise, in other 2 branches, they are different colors. So 3 and this cancel, 1/7. This and this also cancels, 2/7. Answer is 3/7 is the probability that both are of same color. C. Given that Carl has 2 socks of the same color, find the probability that he has 2 brown socks. Okay, probability, we have to find that probability 2 brown socks given that they are of same color. So what we can do, let me call this as A and this as B. So probability of A given B is probability of A intersection B divided by probability of B. Probability of same color we already found 3/7. So the denominator is already decided, 3/7. Now probability of 2 brown socks will be this brown and brown here, which is 1/7. This is what we got, 1/7. The 1/7 over 3/7, 7 and 7 cancel. Answer is 1/3. This is the probability that they are both brown given that they are of same color. Okay, let's move on to the next one. Question number 5. In question number 5, a ball is dropped from a height of 1.8 meters. Okay, so that means this height from here till the ground is 1.8 meters. Okay, and bounces on the ground. The maximum height reached by the ball after each bounce is 85% of the previous maximum height. That means this height second time will be 85% of 1.8 meters. That's what they're saying. Okay. Show that the maximum height reached by ball after it has bounced for the sixth time is 68 centimeters to the nearest centimeter. Okay. Sixth time, bounced for the sixth time. So this is first time, this is second time, this is third time, this is fourth time. So let's see a pattern in this. Our initial one, let's say the first, before first bounce, right? Before first bounce, the height is 1.8 meters, right? After one bounce, after first bounce, it will be 85% of this, which is 0.85 times 1.8. This is how we find out 85%, right? 85 divided by 100 is 0.85 times 1.8, right? After second bounce, it will be 85% of this height, which is 0.85 times 0.85 times 1.8, right? Which is 0.85 square times 1.8. It means this exponent will keep on going till sixth. They're saying maximum height reached, here, bounced for the sixth time, and after that, after it bounced. So after, we'll keep on the same pattern. After sixth bounce will be 0.85 to the power 6 times 1.8. Put in this a calculator, and I'm sure this is going to be 68 centimeters because it is in meters. So we'll get 0.68 meters, which is equal to 68 centimeters. Please confirm yourself. Find the number of times after the first bounce, number of times after the first bounce that the maximum height reached is greater than 10 centimeter. So this pattern or this one is after first bounce only, right? After first bounce it is this, right? After first bounce it is this, after second bounce it is this, after sixth bounce is this. So let's see, whenever it reaches 10 centimeter, every height before that bounce will be the number of bounces, number of times. It will be more than 0. This 10 centimeters. So what I'm trying to say here is this. We know that it is 0.85 to the power n times 1.8 has to be greater than 10 centimeter, which is 0.1 meter. Because this is meter, we have to keep this in meter, and thus we have to solve this inequality. For solving it, we will write log in front of both of them. Let me write log here and log here, so that this n comes down as coefficient of this part. Okay, before it comes down, we have to separate these two. They are multiplying inside, so it will be log 0.85 to the power n plus log 1.8. Yeah, whenever we separate the contents of a log, they add up as different logs. Is greater than log 0.1 will be here. Now log 0.1 is there, it is 1 over 10 to the power minus 1, so we know this will be minus 1. Just put this in a calculator, and we will put this log 1.8 also to the right side, log 1.8. Alright, so now what are we left here? We left with only this, and this n, the purpose of writing log was that this n should become a coefficient according to laws of logarithm. So it becomes n log 0.85, right? And now we can write this one is minus 1.2553. Okay, and n log 0.85. Now we will divide both sides by log 0.85 divided by log 0.85, and keep in mind, whenever we find log of a number which is less than 1, it is always negative. That means we are dividing both sides by a negative number. Whenever we divide by a negative number, the inequality changes. So this will become less than now because we divide by a negative number. If you put this in your calculator, you'll get a negative number. It cancels here. N is less than, and if I put this, a negative divided by negative will be positive, and what I am getting is 17.784. That means our N has to be just less than 17.785, rather 4 it was. So N equal to 17. It is the 17th bounce before which it will bounce 17 times. After that, it will go below 10 centimeters or 0.1 meters. Part C. Find the total vertical distance traveled by the ball from the point at which it is dropped until the fourth bounce, means until after third bounce, right? Fourth bounce, okay, 1, 2, 3, 4. Okay, this is what that's saying. So we know first one is 1.8. Let me have some space here. So first height is 1.8, right? Plus second, this one will be twice because it is going up and coming down. So it is going vertical distance twice. It is 0.85 times 1.8. Then we have this distance, which will be again twice 0.85 square times 1.8, and then twice 0.85 cube times 1.8. Just put this carefully in your calculator and you get the answer. I'm using my calculator. By the time I do this, I would request you to hit that thumbs up icon and subscribe to my channel. Thank you very much. I got 9.67 meters. All right, let's move on to the next one, which is question number 6. Question number 6 says a vertical pole stands on a sloped platform. The bottom of the pole is used as origin. So the coordinates of this point are 0, 0, 0 of the coordinate, okay, and top F is 005.8. All units are in meters. The pole is held in place by ropes attached in F. So it is very clear that it is a three-dimensional space in which this pole is being drawn and expressed. One of these ropes is attached to the platform at this one. The rope forms a straight line from A to F. Okay, find the vector AF. Okay, so we can say that vector AF will be the position vector of F, because the head is here, minus position vector of A. So OF, whatever are the coordinates, become the vector. So it will be 0, 0, 5.8 minus OA 3.2, 4.5, negative 0.3. So it will be 0 minus 3.2 minus 3.2, 0 minus 4.5, negative 4.5, 5.8 plus 3. Because of this negative and negative, it will become 6.1. That's the vector AF. Find the length of the rope. So basically AF is the vector. They are asking its magnitude. So the magnitude of this vector will be square root square of this component minus 3.2 square plus negative 4.5 square plus 6.1 square. It comes out to be 8.228. So 3 significance will be 8.23 meters. Okay, find FAO. FAO, this angle. FAO, the angle rope makes with the platform. Okay. So this is 0, 0, 0, right? This is original. So this OA is actually the position vector, which is this particular coordinate in form of vector. So angle FAO, let's call it angle A, will be by using the dot product cos inverse first vector, which is 0, no, not 0, 0. This is the vector, right? We're finding this angle, so we'll take this vector as well as this vector, and AF is already known to us, minus 3, 2, so minus 3.2, let me write in algebraic format, minus 4.5 J plus 6.1 K dot this 3.2 I, the position vector of OA, and plus 4.5 J minus 0.3 K. The dot product divided by the magnitude of this, which is 8.23, we already know, and multiplied by magnitude of the second vector, which is 3.2 square plus 4.5 square plus negative 0.3 square. So it comes out to be cos inverse negative 3.2 times 3.2 will be negative 10.24. Negative 4.5 times 4.5 will be negative 20.25 minus 6.1 times negative 0.3 will be minus 1.83. Okay, divided by 8.23 we already knew, and this comes out to be 5.5299. Okay, just put this in the calculator, which comes out to be 135.2616. But if you notice, it is an acute angle here. We are getting an obtuse angle. Why? Because we took a vector AF, which is from A to F, this direction, and the other one is OA in this direction. They are head to tail. The angle between two vectors is always either tail to tail or head to head. So basically we got, if I draw it further, this will be the direction of OA, right? And now they become tail to tail. So this is the angle we got. And we are not interested in this tail to tail angle. We are interested in the angle which they are making here. So to find the other actual angle, we write the angle between rope and platform. It will be 180 minus 135.2616, which is 44.7384. So run it off to 44.7 degrees. This will be the required angle. Question number 7. This question is about a differential equation x square plus y over 2. Some of the solutions to the differential equation have local maximum points and local minimum points. These are the solution. This is slope field. Write down the equation of the curve on which all these maximum and minimum points lie. We have to write the equation of the curve, the combination of all maximum and minimum points. Okay, so what we can do, we know that this part A, at maximum or minimum, gradient which is dy over dx is equal to 0. So in this equation, we will make dy over dx equal to 0. 0 equal to x square plus y over 2. Let's bring x square to the left side, so it becomes minus x square equal to y over 2, and cross multiply here, and we can write our answers minus 2x square equal to y, or y equal to minus 2x square. This is the equation of the curve on which all these maximum and minimum points lie. Sketch this curve on the field. We can do it two ways. We know how to draw the curve minus 2x square, right? Minus means it opens down. The shape will be something like this, and we can substitute the values of random x and y. Let's say 1. If I put this x equal to 1, so 1 square will be 1 times minus 2 is minus 2. So 1 minus 2 is one of the points, and we can see that it is turning back here, right? Similarly, we can put 2, we can put 3, and all these. But the easier one is that we know these are the maximum points. Can you see? Maximum. Somewhere here. Just join these maximum points which are visibly evident to you. So you can just join them. And this is how you can get the value of. Now at this side we have minimum points. These are the minimum points. Okay, now what? The solution to the differential equation that passes through 0 minus 2 has both a local maximum and a local minimum. So on the slope field, sketch the solution of the differential equation that passes through 0 minus 2. So 0 minus 2 is here, this one, and the dot which is passing through this is the solution, okay, which is our focus. Not that good, but yeah, I can trace the dots which are passing through that point. This is the solution which is passing through 0 minus 2. It has a maximum, it has a minimum too. Okay, let's go to question number 8. Question number 8 has a curve 2x of 4 minus e to the power x. Find dy. Oh, we have to just differentiate this. So y is equal to 2x 4 minus e to the power x. Now we want to find dy over dx in a part. So since there are two parts which are multiplying and both have variables, so we can use product rule. So we will differentiate 2x, but we will not do anything to 4 minus e to the power x, plus 2x remains what it is. We will differentiate 4 minus e to the power x. Okay, so differentiation of 2x is just 2 4 minus e to the power x plus 2x. Differentiation of 4 will be 0, no need to write, and minus e to the power x will have differentiation minus e to the power x. And they are not asking us to simplify, but let's see. If we open the bracket, it becomes 2 times 4, 8 minus 2 e to the power x plus, rather not plus, minus because of this minus 2x e to the power x, and we cannot simplify it further. So that will be dy over dx. Second is find d square y over dx square. That means second derivative of the same function. So we'll differentiate this one. Differentiation of 8 is 0, so don't even look at it. Next one, minus 2 e to the power x. The differentiation of e to the power x is e to the power x itself. Then again we are two parts are multiplying, so we'll have to use product rule in this. So minus 2x differentiated e to the power x not, plus 2x remains 2x, but e to the power x is differentiated. So minus 2 to the e to the power x minus differentiation of 2x is again 2 e to the power x. This minus will apply to this plus also. So minus 2x remains 2x and e to the power x is e to the power x. This is okay. We can take something common here. So let's take minus 2 e to the power x common. So this is 1, this is plus 1, right? Both are negative, so we have taken negative common. So 1 plus 1, 2. This minus 2 is out, this is out. So plus x. This is the second derivative. The curve has a point of inflection AB. Find the values of AB. Point of inflection is when the second derivative, let me write here, second derivative d square y over dx square is 0. That means at point of inflection concavity changes. The rate of change changes. And for that this has to be equal to 0 because this is the second derivative. Minus 2 ex 2 plus x equal to 0. So it has two factors. Minus 2 e to the power x is 0 or 2 plus x is 0. 2 minus 2 cannot be 0 and e to the power anything cannot be 0. Even e to the power 0 is 1. So this is an invalid equation which we reject. So our answer will be here, x equal to minus 2. And which is the value of a, the x coordinate of the point of inflection. This is a equal to minus 2. Okay. Question number 9. A company produces bags of sugar and with a labeled weight of 1 kilograms, the weights of the bags are normally distributed with a mean, okay, equal to 1 kg. Yeah, 1 kg. And standard deviation equal to 100 grams, which can be written as 0.1 kg. Yeah, 100 grams is 0.1 kg. If the weight of a randomly chosen bag is less than 950, then the company fails the inspection. Okay, that means they will reject that bag. Find the probability that the company fails the inspection. Okay, so let's visualize this. This is 1 kg and standard deviation is 0.1 and suppose this is 950 grams, right? They're saying 950 grams. So 950 grams equal to 0.95 kilogram. So this is 0.95 and we want the probability that it fails. That means it is less than 0.95 kg. So first we have to find z for x is less than 0.95. And that will be 0.95 minus 1 divided by what is the standard deviation? 0.1. So 0.05 negative 0.05 over 0.1, which is negative 0.5, negative 0.5. This is the z score and we have to find now p for z less than negative 0.5. For that we need to use our calculator. Okay, I have p here, so I will just put negative 0.5 and that comes out with 0.3085. Okay, 0.3085. Uh, 85 I can write it as 9 because 3 significant figures we have to write and find the probability that the company fails the inspection. This is the probability that company fails the inspection. A statistician in the company suggests it would be fairer if the company passes the inspection when the mean weight of 5 randomly chosen bags is greater than 950. So number of bags chosen are 5. So mean they want more than 0.95 kg, and variance was 0.1, right? But we want variance for the sample. So variance for sample, which is x bar, will be 0.1, the variance of the original one divided by, rather this is the variance, right? Not standard deviation. This was standard deviation. So variance divided by n, which will be 0.01 divided by 5, 0.002. That's the variance. Okay. Now we want the probability. First let's find the z score, that x bar is greater than 0.95. So we'll write 0.95 x bar minus the mean of the sample, and the population will be same. Okay, but the standard deviation will be square root of 0.002 equal to negative 1.118. And we want the probability greater than negative 1.118. That means, going back to our calculator, r minus 1.118, right? Yeah. Okay, it is already there. 0.868, 3 significant, 0.868. So we got our probability that x bar is more than minus 1.11, not x bar, z, is 0.868. This is the probability. Okay. Question number 10. The following Argand diagram shows a circle with center at 0, radius 4. Okay. A set of points z theta on the Argand plane and defined by z theta equal to half theta e to the power theta I. Okay. Plot on the Argand diagram the points corresponding to theta equal to pi by 2. Okay. So A, part 1, theta is pi by 2. So z pi by 2 will be half pi by 2 e to the power I pi by 2. So it becomes pi by 4 and e to the power I pi by 2. That means this becomes the modulus, this becomes the argument, right? So modulus is pi by 4, and pi by 4 will be somewhere here. Okay, this is pi by 4, right? But the direction has to be pi by 2 positive. So pi by 2 positive, this one will be the first point. Can I name it something else? Okay, let me name it as A, and I will write this as A. This is the point A, which the argument is pi by 2 and modulus is pi by 4. Okay, let's go to the second one, pi. Theta equal to pi. So z pi, which let me name as B, which will be denoted by B, okay, will be half pi e to the power I pi. So the modulus is pi by 2, but in the direction of pi. Pi by 2, this is the modulus pi by 2 till here. Till here is pi by 2 and the argument is pi. So this is B. Okay. Let's move on to the third point. And third point I will call it C. Z 3 pi by 2 will be theta, not theta, half pi 3 pi by 2 e to the power I 3 pi by 2. So 3 pi by 2 is positive 3 pi by 2, right? Is the argument from here till here. Okay. Let me undo this one and show you with the other one. Basically this line, and the modulus is 3 pi by 4. 3 pi by 4 will be exactly between pi by 2 and this point here is C. Consider the case where z theta is equal to 4. Z theta is equal to 4. So on this circle, z theta is equal to 4 because the radius from here to here is 4 on every point of the circle. Alright. Find the value of theta. So we can write B. Number 1. Okay, z theta. The modulus, which is here. So half theta is equal to 4, right? That means theta is equal to 8, right? So z theta, they're saying find the value of theta. Okay, find the value of theta is 8. For this value of theta, plot the approximate position of z theta on the Argand diagram. So we know theta is 8. That means this is the argument, and modulus is already given as 4. So on this circle, where is the argument 8? So this is 3.14, yeah, 14. Then we come back to this one, it is 6.28, yeah. I go from here, full circle, 2 pi is equal to 6.28. And this is 1.57 more than 6.28, which comes out to be 7.85. So it will be 7.85 here. Yeah, 6.28 plus 1.57. Okay, that means 8 has to be somewhere. This is approximate, right? So 8 has to be in this direction. So let me draw. So it is reaching somewhere here. So I will put approximate place of Z. This one is here, this point. Question 11. The matrix this has eigenvalues negative 0.5 and 1. They have already given it, so we don't have to do much. Find the eigenvector corresponding to the eigenvalues 1. Okay, eigenvalue 1, this one only. Give your answer in this format. Okay. So when we have eigenvalues, we know that 0.2 minus eigenvalue and 0.8 and then 0.7, 0.3 minus eigenvalue. The diagonals are subtracted by eigenvalues, and then we have eigenvector here has to be equal to a 0 vector. So now we have been given that lambda is 1, and that's what we have to use. So it becomes 0.2 minus 1. Lambda is 1. Okay. So negative 0.8, 0.8, 0.7 and 0.3 minus 1, negative 0.7 x y equal to 0, 0. And now we can use this first row. Negative 0.8 times x is negative 0.8x. 0.7 times y is 0.7y has to be equal to 0. So negative 0.8x equal to negative 0.7y. So divide both sides by 0.7, no, 0.8 negative, so that it goes to the other side. And we divide both sides also by y. So y and y cancel here. Negative 0 point cancel here. These two negatives become positive. So what do we get? X over y is equal to 0.7 over 0.8. We can multiply up and down by 10, becomes 7 over 8. So the ratio of x and y is 7, 8. So we can write 8x equal to 7y if we want to write. But we know that the ratio is 7 over 8. So eigenvector will be x is 7, y is 8 units. This is the eigenvector in this format. A switch has two states, A and B. Each second it either remains in the same state or moves according to the following rule. If it is in state A, let me write probability. Let's introduce here. Let probability of being in state A equal to P. So probability of state B will be 1 minus P, correct? So they're saying here that if it is in state A, it will move to state B with a probability of 0.8. So if it is in A, it will move to state B with a probability of 0.8. If this is state A, this is state B, that means the probability that it will stay in state A will be 0.2. Again, if it is in state B, the probability of it going to the probability state A is 0.7. So state A 0.7, that means staying in state B will be 0.3. This is the matrix that will show that transformation. And is it matching? Yeah, it's matching with matrix M. Can you see here? All right. So what is the question? Using your answer to A, this one, or otherwise, find the long-term probability of the switch being in state A. Being in state A, this state. Okay, long-term. That means if probabilities are P and 1 minus P after some state, say after 20th state, the probability remains that in next stage also. Even after applying this matrix, the probability remains what it is. So let's compare state A, because they're saying find the long-term probability of switch being in state A. So that means being in state A, we assumed as P, we have to find P. So let's find the P, an equation in terms of P. So 0.2 times P, 0.7 times 1 minus P has to give us P. Okay, and that becomes our equation. We'll find P through this. 0.2P plus 0.7 minus 0.7P equal to P. 0.2 minus 0.7 is negative 0.5. 0.7 minus 0.5P equal to P. Let's bring this P to the right side. So 0.7 equal to P plus 0.5P. 0.7 equal to 1.5P. So divide both sides by 1.5, 1.5. Let's complete it here. Cancels. So P comes out to be 0.7 over 1.5, and to make complete integers, because this is in the form of C over D and D have to be integers, we have to complete them. 0.7 times 10 is 7 and 1.5 times 10 is 15. 7 over 15 is the probability that it will remain state A after long term. Okay, question number 12. The strength of earthquake is measured in Richter scale, okay, with values typically between 0 and 8, where 8 is the most severe. The Gutenberg Richter equation gives the average number of earthquakes per year n, which have magnitude of at least m for a particular region in this equation is given. Okay, this region has an average of 10 earthquakes per year, and earthquakes per year is n. That means they are trying to say in n is equal to 100. Okay, with a magnitude of at least 3, and which have a magnitude of at least m. That means m is 3. Find the value of A. So log base 10 100 equal to A minus m is 3, and that's it. Okay, log base 10 100 is 2 equal to A minus 3, and then when A comes to the left side, A becomes 2 plus 3, which is 5. The equation for this region can also be written as n b over 10 to the power m. Find the value of b. That means they are asking us to transform this equation into this format. Okay, so we can see that n is alone here. That means log has to go. When log goes, the other side becomes the power of the base. So it will be A minus m, and A is 5. So let me erase A and write 5. Okay, so n is 10 to the power 5 divided by 10 to the power, and which can be written as 1 2 3 4 5 over 10 to the power m. And that's why this, if you compare with this equation here, b comes out to be 100,000. What about C? Within this region, the most severe earthquake recorded has a magnitude of 7.2. Okay, find the average number of earthquakes in a year with a magnitude of at least 7.2. At least 7.2. Okay, so at least means m is 7.2. Okay, average number of earthquakes, what is n? Okay, A is already with us, 5, so we'll do that. So log base 10n equal to 5 minus m. M is 7.2. So I want n, right? So n will be 10 to the power 5 minus 7.2 is minus 2.2. So n equal to, okay, calculator gives 6.3095 10 to the power minus 3, which can be written as 0.0063095. Okay, so it will not be proper to write this way. This is fine. Okay, we'll write this way. Okay, next, the number of earthquakes in a given year with a magnitude of 7.2 can be modified by Poisson distribution with mean n. Okay, so n we just got this one. The number of earthquakes in 1 year is independent of the number of earthquakes in any other year. Let y be the number of years between the earthquakes of magnitude 7.2 and the next earthquake of at least this magnitude. Find Py is greater than 100. That means there is no earthquake in 100 years. That's what they're saying. It will be after 100 years. So what is the expected number of earthquakes? In 1 year, these many earthquakes can be there. So in 100 years, 100 years, it will be 100 multiplied by 6.3095 times 10 to the power 3. So 100, there are 2 zeros here and there are 3 here. That means it will be 0.63095. These many earthquakes, not even one earthquake, is expected in 100 years, right? But we want 0. We want, this is lambda for us, we want probability that x is equal to 0. Number of earthquakes in 100 years is 0, and the mean number of earthquakes is this. We know this will be lambda to the power x e to power. I'm doing it manually. You can also use a calculator. Just in Poisson distribution, plug in this x equal to 0 and give that lambda mean is this, and you will get your answer. And here it will be x factorial. So lambda is 0.63095 to the power 0, and e to the power minus 0.63095 over 0 factorial. So 0 factorial is 1, so it's insignificant, and this also 1. Something power 0 is also 1, so gone. Only this is left, e to the power minus 0.63095. Let's put this in our calculator. E to the power 0 minus 0.63095. I get 0.532086. Okay, enough, but we have to round up to 3 significant figures. So we can write 0.532 is the probability. Alright, let's move on to the next question, which is question number 13. At 1 p.m., a ship is 1 kilometer east and 4 kilometers north of harbor. Okay, so suppose this is harbor and this is 1 kilometer to the east and 4 kilometers, 1, 2, 3, 4 kilometers north. Okay, so here is the ship. The position vector of the ship at 1 p.m. is given by 1, 4. So 1, 4, that means this has been, harbor has been taken as origin. Okay, the ship has a constant velocity of 1.2 minus 0.6, 1.2 positive x, negative y. That means this ship is moving this direction. Yeah? Okay. 1.2 minus 0.6, that is the vector. Okay. Kilometers per hour. This is kilometers, hour, kilometers, and kilometers. Okay. Write down an expression for the position vector of r, position vector r of the ship t hours, right? Again, it's matching. So nothing to be changed after 1 p.m. So basically it will keep on going here. Suppose it reaches here after t hours, right? The speed is, the velocity rather, 1.2 minus 0.6. So this displacement from here till here will be t times 1.2 minus 0.6, and it reaches here. They are saying find a position vector for, expression for position vector of this point, this particular point. So the position vector will be from harbor to this. This will be the vector r. Okay, to find this we will do what? We will first write the vector up to s. So vector r will be hs plus, then from here till here we reach, and this vector plus this vector will be r. So hs plus, let's call it, okay, we have its value, so let's write t 1.2 minus 0.6, no need to name it, but we will name HS has been given to us 1, 4. So R is equal to 1, 4 plus T 1.2 minus 0.6. So it comes out to be 1 plus 1.2T and 4 minus 0.6T. This is the vector in terms of T. Write down the time at which the bearing of the ship from the harbor is 45 degrees. So 45 degrees, this will be north. This angle is 45 degrees, right? That means if I join this line up to here and then to this is 45 degrees. Let me redraw this here. So this angle is 45 degrees, right? And this is vector R, right? So we know that, and this particular position vector, because it is, what is that? 1 plus 1 plus 1.2T. I'm writing the coordinates. The position vector can be written as coordinate of the head, and 4 minus 0.6T. All right. This, for 45 degrees, whenever we have 45 degrees, the adjacent side and the opposite side both are always equal, right? Then only it is 45 degrees, because tan 45 degrees is 1. And it is for this reason it is 1, because the adjacent side and opposite side are equal. That means this coordinate, which is the horizontal distance from H, is equal to the vertical distance from H. That means X and Y coordinate of this head are equal. So that's what we're going to do. 1 plus 1.2T equal to 4 minus 0.6T. Let's bring it here. So 1.2T plus 0.6T equal to 4 minus 1. This one comes to the right side. 1.8T equal to 3. T equal to 3 divided by 1.8. So is 30. I'm doing it manually. Please do your calculations with the help of calculator. So 5 over 3 hours. 5 over 3 hours after it left at 1 p.m. here, it reached here, and the question is find the time at which the bearing of the ship is this. So 5 over 3 hours after 1 p.m. So 1 plus 5 over 3, because I'm taking 1 p.m. as one number, okay? So it will be how much? 8 over 3, which in mixed fraction, it will be 2 2/3. But we can't give time as 2 2/3, right? So this has to become minutes. So let's convert 2/3 multiply by 60, it will give us minutes. So 20, 2 times 20 is 40 minutes. So we will write the time of having 045 bearing is 2 hours, 2 and 40 minutes, because 1 is part of it, right? It's not after 2 hours, it is 1 plus I added this, so it became 2:40 p.m. That is the answer. After 1 hour 40 minutes, it will be at that position. Okay. Question number 14. Question number 14 says expand this. Nothing can be easier than this. So A, we have to expand 1 over u plus 1 whole square. So you must know this identity. A plus b whole square is a square plus b square plus 2ab. And that's what we're going to do here. A square plus b square plus 2ab. So it will be 1 square is 1, u square is u square plus 1 2 times 1 is 2 times 1 is 2 over u. This is the expansion of u1 plus u1 over u plus 1 whole square. Okay, find f. No, it's not f, it is integration. Okay, so we have to integrate this. So in place of u, now we have x plus 2, and in place of this u we will write x plus 2, and that's what we have to integrate. Let me do it here. Integration of 1 over u square, sorry, not u square, x plus 2 square dx. I'll separate all three, okay? We can do that. Plus 1 is just 1, so we'll write just dx, plus 2 over u, let me write 2 outside and 1 over u inside. It becomes easier. And not u, x plus 2. Okay, so x plus 2, if can I write this x plus 2 as x to the power minus 2? Yeah, and that's what I'm going to integrate now. X plus 2 to the power minus 2, and we will add 1 to it to integrate, and we will write the same down there. Plus, there is nothing here, that means 1 dx is, the integration is just x. 2 is 2, and 1 over a linear expression is always natural log. Ln x plus 2 divided by the differentiation of what is that linear, but differentiation of x plus 2 is just 1. So even if you don't write it, it's okay. And plus c. So this minus 2 plus 1 will make this whole thing negative. X plus 2 to the power negative 1 plus x. Did I write 2 plus? Nope, I didn't have to write this one. 2 was multiplying with this, right? So it will be plus ln x plus 2 square. Why? Because this is a coefficient multiplying here, so it will go and become its exponent here, plus c. Okay, let's make this positive also, this negative. So I'll write this, because this is negative, I'll write it later. So let me write x first, then I will write 1 over x plus 2. That's what it will become. Plus natural log x plus 2 whole square plus c integrated. The region bound by y equal to 1 over x plus 2 plus 1, x plus 2 plus 1, this one, x equal to 0 and y equal to 2. Okay, let me try to visualize this. Suppose this is the graph. I'm not saying this is the right graph, but I'm saying just suppose this is the graph. So x equal to 0 is here, this line. X equal to 2 is here. Okay, then the graph is this x-axis. Okay, this is the x-axis, and now it is rotated about x-axis. So that means this will become a drum like this, if it was the right graph. Okay, I've just assumed it that this is the graph. So 2 pi degree means full 360 degrees. Find the volume of the solid. Okay, so whenever we need to find the volume of such a solid, this is what we do. We write pi and radius of that rotation, but that radius is variable. Here it is less, here it is more. So we write the one which is integrate this one. 1 plus x plus 2 plus 1. This was y, right? So y square dx. This is how we find the volume by rotation of this function by 360 degrees or 2 pi about x-axis. And we have already integrated this. This is the answer of integration. And we have to write from 0 to 2. So let's substitute these 0 and 2 here and write pi in front. That's what it will be. So pi. Okay. And let me substitute 2 first in this integration. 2 minus 1 over 2 plus 2 plus natural log 2 plus 2, 4 square. Okay, plus c minus 0. We have to substitute 0 also, right? This 0. 0 plus minus 1 over 0 plus 2 plus natural log of 0 plus 2, 2 square plus c. First thing first, c is cancelled out. Okay, so 2 minus 1/4, 2 minus 1/4 plus ln 16 minus, not minus, this negative and this negative will be positive, so plus half, plus, but this minus will make it negative, minus natural log 2 square is 4. So 2 minus 1/4 plus half will be 9 over 4. This is natural log subtracting, so it will be plus 16 over 4. When they subtract, their contents divide. So it comes out to be 9 over 4 plus ln 4. This will be the final one, but we ignored this pi till now, so we will write pi here, and pi here. And this format does not match because we need this 4 outside. That means we will divide by 4 and multiply by 4, right? So this pi by 4 remains pi by 4, but inside 9 over 4 times 4 will be 9. Then 4 times ln 4, they want something in front of ln also. Alright, so that's what we got. Now everything is matching here. So our A is 9, B is 4, and C is also 4. This is the solution they wanted. Alright, question number 15. The number of cars arriving at a junction in a particular town in any given minute between 9 a.m. and 10 a.m. 1 hour is historically known to follow Poisson distribution with a mean of 5.4 cars per minute. Okay, that means mean is 5.4 per minute. Let's see, they ask a minute or hour later. A new road is to build near the town. It is claimed that the new road has decreased the number of cars arriving at the junction. Okay. To test the claim, the number of cars X arriving at the junction between 9 a.m. and 10 a.m. a particular day will be recorded. Okay, that means mean has to change. It will become 5.4 times 60. That will be 324. Okay. The test will have the following hypothesis. Null is mean number of cars arriving at the junction has not changed, and alternate is it has decreased. Okay. Alternate hypothesis will be accepted if x is less than or equal to 300. Assuming the null hypothesis to be true, state the distribution of x. So since it is a Poisson distribution, it will be mean is 324 because we are calculating for 1 hour. B, find the probability of type 1 error. Okay, if this is the mean, which is 324, and we will say that it is null hypothesis is false. It has decreased if it is less than 300, right? Alternate hypothesis will be accepted. That means null hypothesis will be rejected if it is less than 3. So this will create a kind of mistake here. Okay, so now we have to find for x equal to, rather not equal to, less than equal to 300, what is the probability? This will be the type 1 error. Type 1 error is when it is true, but we call it false, and we'll call it false for this region. Okay, so we can use our calculators for this. So we can use this one here, Poisson distribution we want. So okay, Poisson distribution, our mean is 324, that's what we want. but we want less than 300, so automatically whatever number I put here, that will be less than this, and we already got it 0.0947, 0.0947. So this will be the probability, 0.0947. That's for type 1 error. Find the probability that the type 2 error, if the number of cars now follows a Poisson distribution with a mean of 4.5 cars per minute. So our lambda will change here, 4.5 times 60 now. 240 plus 30, 270 is the mean, and we want type 2 errors. So if 270 is mean and 300 we want here, and type 2 error, we want type 2 error. In type 2 error, the thing is false, but still we write it correctly. So if this 270 is the mean, it could be false here, but by mistake or by error we can, because more than 300 we are accepting null hypothesis, right? So we can say it is true here, or whereas it is false. That means we have to find the probability of this area. For that we will write probability of x is greater than 300, then it will be type 2 error. But our calculator will give only us less than 1, so we can write it 1 minus probability of x is less than equal to 300. So this less than 300 will give us this probability less than 300, but we want more than 300, so we'll subtract it from 1 and we get the right one. So let's move on to our calculator once more. Okay, so in place of 324 now I will write 270. 0.967, yeah, 0.967 I can write here, 0.967. So it becomes 1 minus 0.967, and which comes out to 0.033, and we wanted one more digit because it is not giving us. So 9666, that's what we can do, yeah, 9666. okay, so it will be 9666, and now we'll get 0.334. This is the probability of type 2 error. Okay, question number 16. The wind chill index W is a measure of the temperature in C degrees Celsius felt when taking into account the effect of wind. When Fredo arrives at the top of a hill, the relationship between the wind chill index and the speed of the wind is this. Find the expression for dW over dV. In other words, they are simply asking us to differentiate this. So dW over dV. Differentiate this with respect to V. Since 19.34 is a constant, leave it. Its differentiation will be 0. Minus 7.405, and we will bring 0.16 in front, and V to the power 0.16 minus 1. This will be the differentiation. So dW over dV is a 0.16, right? 0.16 multiplied by 7.405. 1.1848 and negative. V to the power 0.16 minus 1 will be minus 0.84. Are they saying something? Find an expression. And okay, let's make it positive. Negative 1.1848. over v to the power 0.84. This is dw over dv. Okay, when Freda arrives at the top of a hill, the speed of the wind is 10 kilometers. V is 10 kilometers per hour and increasing at the rate of dv over dt. The velocity of the wind is increasing at 5 kilometers per hour per minute. Every minute it is increasing this way. Find the rate at which the change in w at this time. Okay, so it's per minute. Okay, this kilometer per hour is 1 unit, so don't bother about this hour and this minute. This is separate, this is separate. So we will use our expression which was here. So let me write it again. dw over dv was minus 1.1848 over v to the power 0.84. Now, since time is involved now, so we will write rate of change of wind chill divided by dt, rate at which speed is changing divided by dt. So by chain rule we can do this. This is what they're asking. Find the rate of change of w. This is the rate of change of w, dw over dt. So dw over dt will be equal to, this will multiply here, minus 1.1848. So it will be 10 to the power 0.84. And now dv over dt, which I ignored here, will go and multiply here. dv over dt is given as 5 kilometers per hour per minute, so just 5. Whatever will be our answer, it will be per minute because this is per minute. And by the time I use my calculator, I would request you to hit that thumbs up icon, share this video with your friends, and subscribe to my channel. My number of subscribers are very low at the moment. I need your support. Thank you very much. What I'm getting here is negative 0.856278. Okay, I have to round it off to 3 significant figures, which will be negative 0.856. Okay, the unit of wind chill was degrees Celsius per minute. That means this wind chill is reducing. The temperature is reducing at this rate. Finally, let's go to the question number 17, the last of the lot. A function f is in the form of this, so many variables. Let me rewrite this, may not be clear there. ft is equal to p e to the power q cos r t. P, Q, R are real numbers. Part of the graph is shown here. The points A and B have coordinates these two. Okay. And lie on F. The point A is a local maximum and point B is a local minimum. Find the value of P, Q, and R. It's worth 8 marks. Okay. So, first of all, we should see that these are turning points, maximum and minimum, right? So what can we do? We can find the first derivative of this one. So P is a constant, it is untouched, and e to the power this will remain what is here, q cos rt. But further we will differentiate the exponent and multiply with this by chain rule, right? So q is a constant again, so q remains q. Cos, the differentiation of cos is minus sine rt. And then we differentiate the angle as well. So since t is power 1, so the differentiation of this will be r. So let me write it again. P, this P, Q, R, and this negative will make it the whole thing negative. Let me erase it so that it is visible properly, otherwise sometimes I forget. Minus PQR, and we can write sine RT e to the power q cos RT. Since these 2 points are minimum and maximum at these points, the gradient of the tangent, which is dy over dx, f prime t in this case, the gradient is 0. That means this has to be equal to 0. This, and this. There are 5 parts which are multiplying. That is, one by one we can see if they are equal to 0. Since they said it's a real number, positive real number, that means that's not a possible. So we can't have this value. Q also cannot be 0. R also cannot be 0. That means surely sine RT is equal to 0. But e to power q cos RT can also not be equal to 0. Why? E is a variable, right? 2.71828. It's no matter what is its exponent, it will never be equal to 0. Even if t is 0, r is 0 or q is 0, e to power 0 is 1. It is not 0. So this is also rejected. So this is the one which will come to our rescue. This will help us to find. So RT equal to sine inverse 0. We can see that there is straightforwardly at 0 it is there. So that means the first answer itself will be RT equal to sine inverse 0, 0. But since they said R cannot be 0, that means T is 0, and yes, we can see that T is 0 here. So this did not give us anything new. So what are we going to do? We're going to use the second answer. If you remember, sine graph looks like this. So it is 0 at 0, it is also 0 at pi, and it is also 0 at 2 pi. But we are going to the next point immediately after 0, so that means pi is the one we're going to use, not 2 pi. So RT is equal to pi, so R equal to pi over T. And where this is the situation, there we know that T, time, is 5.2. Can you see here? So we can write here R is pi over 5.2. We got the value of R. Okay. Let's see. If we substitute this value 0, 6.5, when T is 0, Ft is 6.5. Let's substitute it in the main equation here. So 6.5 is Ft equal to P e to the power Q cos R and 0. Yeah, time is 0. R times 0 is 0. Cos 0 will be 1. So 6.5 equal to P e to the power just Q. Let me see once more. P e to the power Q, and this is 1. Yes. So P comes out to be, or let's leave it like this. We may use it later. So let's call it equation number 1. Let's substitute this one. Here the Ft is 0.2 when same equation P e to the power Q cos R is known to us now, pi over 5.2, and T is 5.2. Yeah, this T is 5.2, Ft is 0.2. That's what we substituted here. So this 5.2 and this 5.2 cancel. Cos pi, if you use a calculator, is -1. So 0.2 equal to P e to the power minus Q, because this whole thing is -1. Alright, this is equation number 2. And now we can divide equation number 1 by equation number 2 to get rid of P, because P is in both. If we divide, it cancels out. So 6.5 divided by 0.2 left side divided by left side, P e to the power Q, P e to the power minus Q. P and P got cancelled. 6.5 divided by 0.2 will be both gone. 32.5. Yeah, equal to e to the power Q minus Q. Same denominator, same base, so their exponents will subtract because they are dividing. So let's complete here. E to power 2q equal to 32.5 2q equal to natural log 32.5, and that gives us q equal to natural log 32.5 divided by 2. Let's see what it is. Natural log 32.5 divided by 2, 1.7406. So we can write 1.74. This is q. And finally we are left with p we have to find, so we can use any of these. Let's use this one. So according to that one, 6.5 divided by e to the power q is p, right? eq, this one e to the power q goes and divides on the other side. So, and q we know now, so p is 6.5 divided by e to the power 1.74, 1.1401. So we can write 1.14 only. That's p, that's q, and we already knew r. If you want, you can convert it to decimal too. So we got all these three and nothing else. We earned 8 marks here. This concludes our video for this exam paper. I hope you liked it. If you did, please give us a thumbs up and subscribe to my channel. Thank you very much.